சார் என்னோட பேர் விமலா. கிரண்.
Hello.
Hello, am I audible?
Yes, sir.
Good evening, sir.
Good evening, sir.
Hi, good evening, everyone. I would just like if you all also open your video so that I can read your expressions
Yes, sir.
that to understand the concepts of art. Are we good to go?
So just a second, I'll just turn on my video.
Hello.
Yeah.
Can you,
Are we good to go?
sir?
Yeah, Tarun, you are clearly audible and visible too. Nitish, you also.
Yes.
Okay. Try everyone if you can open your videos. Yeah. Sankalp, you also visible, and Kanguel. Am I pronouncing it correctly?
Yes, sir. It's Congo whale.
Congo. Okay, I'm sorry. Yeah. So hi everyone. My name is Adarsh, and I am presently in NIT Jamshedpur. Okay. So we are here to discuss with the topic of different topics of physics, right? Different chapters of physics, and we'll be completing each and every chapter in detail while solving the questions also related to the concepts that we'll be dealing. Okay. First, I'll be teaching you the concepts. I'll be giving you the theory, brief theory, and detailed theory also about different concepts that are we dealing with in the due course of time, right? And then what we'll be doing, we'll be solving the numericals related with the concepts, right?
Yes, sir.
Yes, sir.
Any doubt anywhere, you can poke me out there, then and there, or at the end of the topic, or at the end of the classes. Okay.
Yes.
So you can feel free. Okay, feel free to contact me anytime. I won't be irritated if you ask the same question 100 times also. Right?
Yes, sir.
Yes, sir.
The setback, and let us start with the first chapter, that is measurements and experimentation. Okay.
Yes, sir.
So physics, we have to deal with many quantities. Okay, we have to deal with many quantities, right?
Yes, sir.
You must
Yes,
be
sir.
acquainted with these things. Like in class 8 and 6, we have studied a similar kind of thing, similar kind of related topic we have studied. So in physics, we deal with many physical quantities, and that is to be measured because we have to give the answers, we have to give the measurements, we have to give the values. And values, whatever values we give, you must have been heard the term that units should be there with the numbers. Any answer you used to write in exams, then if you miss the unit somehow, so the teacher used to ask you that where are the units? Why haven't you written the units? Right?
Yes.
This answer is
Yes.
incomplete with the units, isn't it?
Yes.
So units
Yes,
are
sir.
most
Yes, sir.
important. Because like if I say that this is you, see, initially you don't have to write anything. I'll ask you when to write, okay, and then the explanation time will go on. Because
Yes.
learning things are more important than just writing it down. If you learn things, it is there in your mind. Writing is also important because that should you retain. But I'll give you time, different time for that. Okay. So first learning, and then we'll be writing. Okay. Yeah.
Yes.
So this is your friend. Let us say that your friend's name is A. Okay, and then you are B. You are here B. Right. So initially, uh, a third member came in the picture, and the third member asked you, your B, you, that tell me how much is the distance between you and your friend A. So you will be answering, if you answer him 5, if you answer him 5, so will that be a precise answer? Will that be a precise
No.
answer?
No, sir.
Why?
Sir,
You have
because
to
there's no
measure it
unit.
first.
Because we have to mention the units, because just giving 5 won't give me the exact detail of that particular friend. If this 5 may be anything, this 5 may be 5 meters, this 5 may be 5 kilometers, this 5 may be centimeters, millimeters, anything. So it is not giving me the exact idea, na? Are you understanding?
Yes, sir. Yes, sir.
Right? So that's why we have to give importance to the units also. To describe anything, we have to give importance to the units also. I hope you are understanding that.
Yes, sir.
Yes, sir.
No doubt till here.
Yes, sir.
So now we'll be dealing with a
No.
term. We'll be dealing with a term fundamental or sir, physical quantities. Physical quantities. First, let me complete writing, then you copy it. Quantities, physical quantities that we'll be dealing with, right?
Yes, sir.
So, what are physical quantities? If I just give you the definition first and then make you explain it. So, all those quantities which can be measured, okay, directly or indirectly. All those quantities which can be measured directly or indirectly, and in terms of which the laws of physics can be expressed. The laws of physics can be. Is this readable? These lines readable to you?
Yes, sir.
Yes, sir.
Okay. Can be expressed are called physical quantities. Okay. So
Yes.
what does these lines mean? Okay. How to remember the things, how to remember this definition. We don't have to, in physics, we don't have to memorize anything. I won't make you memorize anything. Okay. All the things
sir.
you'll be feeling. In physics, it's all about feeling, because you see everything in the picture now. You see everything in the live, right? It's all
Yes, sir.
live. So we don't have to memorize anything. It's nothing like it's some kind of theory is there. All those things will be relating with the live examples. So what are physical quantities? Any quantities that we can measure. Okay, length is a physical quantity because that we can measure. Weight is a physical quantity because that we can measure. Mass or your anything. Time is a physical quantity because that we can measure. Temperature is a physical quantity. Can you give me more such examples?
Density,
Density, very good.
velocity,
Very good. Go on.
Distance,
Distance. Distance again is kind of length only.
speed,
Speed, velocity, all
Volume.
these things terms you have heard about. We have to differentiate also. Okay.
Volume.
displacement,
Volume.
width,
Good. Pardon?
width,
IQ.
displacement.
Width is a kind of length only, na? Isn't it?
Yes, sir.
Correct me if I'm wrong.
Yes.
Wrong. Width is a kind of length or not?
Yes, sir.
Good. Okay.
So
So all
displacement.
these things are what? Physical quantities.
Yes, sir.
Okay. I hope you're understanding this.
Yes,
Yes,
sir.
sir.
Everyone?
Yes,
Yes, sir.
Yes, sir.
Okay, that's good. Kongwe, even you're understanding the same thing?
Yes, sir.
Excuse
Okay,
me,
good.
sir. I just have a doubt. What is
Yeah.
the last word in third line? Physics
Express.
can
Express. EXPRESSED. Express.
Okay, sir.
Yeah. Done, everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Everyone?
Yes, sir.
Yes,
Shankar?
sir. Yes,
Yes,
sir.
sir.
Okay, good. So this was about physical quantities. Then we have to go about your fundamental. There are basically two kinds of physical quantities. I'm changing the page. I hope you all have written this.
Yes, sir.
Yes, sir.
Okay. So physical quantities are of two types. If I just say physical quantities are of two types. What are those two types? One is
Scalar quantities and vector.
no.
quantities. Sorry.
Those are different. Those are different. Nothing to say about sorry. It's all about you have to do mistakes and you have to learn. Fundamental quantities. Fundamental quantities. And then the second thing is derived quantities. Fundamental quantities and derived quantities.
Derived quantity.
Yeah. Now, what are these fundamental quantities and derived quantities? So first I'll be just writing the definition. First I'll be writing the definition, then I'll be explaining it. The physical quantities which can be treated as independent, of other physical quantities. Okay, so the physical quantities which can be treated as independent of other physical quantities, okay, and are usually not defined in terms of other physical quantities, are called fundamental quantities. Okay, so these quantities does not require any other medium, any other quantity to get defined. Okay, you won't be understanding this unless and until I write the definition of derived quantities. Okay,
So
I'm
is fundamental quantities like mass? We don't need any other two quantities.
yeah, not speed. That's why I'm telling you. First, I need to define derived quantities, and I'll give you some examples, and then you will understand what is the exact difference. Okay, so let me write the definition of derived quantities. These are the physical quantities whose defining operations are based on other physical quantities. Are called derived quantities. Okay.
Yes, sir.
First, you all write it down so that I start explaining.
So can you read the derived quantities? The definition
The physical quantities whose defining operations are based on other physical quantities are called derived quantities.
Oh, okay.
Like velocity.
Yeah.
You need
Velocity.
direction and
Write it down fast.
Yes, sir. Done, sir.
Done, everyone?
Yes, sir.
Yes, sir.
Okay. Tarun, done?
Done, sir.
Sankal?
Yes, sir.
Mangoel? Nitish?
Yes, sir.
Okay. I'm changing the page because I need to explain. See, I'm just giving you random examples and you tell me which are fundamental quantities and which are derived quantities based on your understanding of what we have given the definition. So I'm giving few physical quantities that are time, okay, then length, then acceleration. Hope you know the term acceleration.
Yes,
Yes,
sir.
sir.
Okay, then we have mass, then we have velocity, then we have okay, time, length, acceleration, mass is done, velocity is done, then density, okay, and then what else we can have? Let it be till here, let it be till here. So you just give me random okay answers, whatever you have understood. So
Sir,
for
time,
fundamental or derived?
fundamental.
Fundamental.
So length is also fundamental. Acceleration.
First let us talk about time. Time
Time is fundamental.
Time
It's
is
fundamental. We don't
fundamental.
need anything else.
Yeah, like
Okay, fundamental. Okay, I'm not explaining right now. I'll explain after this, after your understanding. Okay, length is what?
fundamental.
Fundamental.
Everyone?
Yes,
Yes,
sir.
sir.
Okay. Acceleration?
Derived.
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 Kongwe?
Yeah,
Okay.
derived.
Tarun?
Derived, sir.
Okay. Mass?
Fundamental.
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 Okay, everyone?
Yes,
Yes,
sir.
sir.
Any doubts, you
Fundamental.
just poke me out. Velocity?
Derived.
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 Sir.
Derived.
Derived. And density?
Derived.
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 Derived. Okay, see here. I think you have understood the terms, but still I need to go in depth that what are fundamental and what are derived quantities. See, density, anyone know the formula?
So
Yes,
mass
sir.
into
Mass
into volume.
mass into volume.
Mass.
No, not mass into volume.
Mass divided
Sorry,
by
mass by
Mass-
volume.
mass
Mass
divided by
mass by
volume.
volume. Mass by
It
volume.
is the ratio of mass divided by volume. Okay.
Mass
Yes,
per
sir.
unit of volume.
You guys are really good. You guys are really good.
Thank you,
You
sir.
know everything. Yeah. So mass divided by volume. Okay, this is my density, right?
Yes,
Yes,
sir.
sir.
This
Yes,
is my
sir.
density. So density is what? Mass divided by volume. Here,
Yes,
see
sir.
here. Okay, now what is volume? If I'm just talking about a rectangular shape, okay, or let me talk about a cubic shape. Cubic
So
shape.
the space it occupies is the volume, sir.
If I'm talking about a cube and its length is L, so what will the volume of this cube?
L into
L into breadth
into
into
L.
height.
no that
Everyone?
Sir,
No,
sir,
sir, L into
sir,
two
if
L,
it's a
sir,
cube,
two
it's
L.
L to the power of
L
3.
square. L square.
L to the power of 3, it's volume.
Yeah,
Okay, L into
Oh,
L into L.
cube. Sorry,
L
L
cube.
cube. L cube.
cube it
Sorry,
is.
sir.
L cube it is.
I thought
Okay.
square.
Tarun,
Yes, sir.
you understanding this?
Yeah, yes, sir.
Yes, sir.
Sure, everyone? It is L,
Yes,
L
sir.
into L
Yes,
into
sir.
L. This is the volume. Length into breadth into height. And for cube, it is everywhere L only.
Yes, sir.
Yes, sir.
Okay. Just give me 1 minute. Yeah. So the volume of the cube is nothing but L into L into L, right? Any doubt, anyone?
No, sir.
Sure?
No,
Yes,
sir,
sir.
no doubt.
Can I write density of this particular mass? Let us say that total mass of this
Yes,
particular
sir.
object is M. So can I write density as mass divided by L into L into L?
Yes, sir. But
Yes, sir.
Yeah,
Everyone?
yes, sir.
yes, sir.
Yes, sir.
Yes, sir.
Okay. So in that case, can I write density as some kind of measure or some kind of operations with mass and length?
Yes.
So what?
Can I write? Can I tell density as some kind of operations with mass and length?
Yes.
Yes, sir.
Sir.
Yes, sir.
Yes. Sir.
Yes. Sir.
You're
Yes. Sir.
understanding or not? Because
Yes,
density
sir.
is what? Density is nothing but we have to like find
Divide.
the ratio of mass and length. Sankalp, any doubt there?
Yes, sir. Sir, but mass is also equal to weight into gravity, right? So how
No, no,
is
no,
it
no,
a fundamental?
no.
Mass
is
is
different.
not mass is not weight
weight-
into gravity.
Mass and weight are two
Sorry.
different terms. Mass and weight are
Weight
two
into
different
gravity.
terms. Okay, mass is just the mass of that particular object.
Mass
Weight
into
is the
gravity is
force-
weight.
The
Earth
weight is
pulling it.
gravity into mass. Weight
Yeah,
is
yeah,
gravity
yeah.
into mass.
Correct, that's correct.
Oh,
Okay, I hope
okay.
that doubt is clear, Sankalp.
Yes,
Okay.
sir. Mass is gravity divided by mass. It will be like
Mass is just the exact weight of the exact mass of that body. Okay, so density can be written as mass divided by length. So we
Yes,
have
sir.
just two fundamental quantities, mass and length, that describes density. Am I wrong?
No,
that. No,
sir.
sir.
No, sir.
Sure. Density
sir.
is a derived quantity which is having relationship between or which is a relationship of two fundamental quantities that are length and your mass, right?
Yes,
Yes,
sir.
sir.
Yes, sir.
There lies the difference between fundamental quantities and derived quantities. Derived quantities use the fundamental quantities to get defined. I hope you're understanding that.
Yes, sir.
Yes, sir.
Derived quantities take the help of fundamental quantities to get defined. You cannot define a derived quantity without the help of any fundamental quantity, right?
Yes,
Yes,
sir.
sir.
You said velocity is a derived quantity. How? Let us define that. Velocity is what? Just
So
distance
speed,
upon
Sir, it's
distance upon speed. No, wait. Sorry.
distance upon
Distance
time.
upon time. Yes, sir.
Everyone?
Yes, sir.
yes, sir.
Yes, sir.
Velocity is this only. So what is
Sir-
distance? Distance. Can I write
Sir,
distance as a
isn't
kind
it,
of length?
sir, isn't velocity distance into the direction?
No, it's distance
No, no,
divided
no,
by
no,
the
no.
time taken.
Yeah.
Total
So
distance divided
velocity is something, and speed is something else. Now you are confusing here. Okay, velocity and speed. Velocity is a vector quantity. Speed is a scalar quantity. We're not dealing into that. Okay, we'll deal with that in later chapters. Okay, the direction is just to specify the in which direction that body is moving. Okay, and that will give it to be a vector quantity status, right? So that is different. We are just defining the exact calculation. The direction does not get into the calculation, right? Kongwei,
Yes, sir.
sure? Your doubt
Yes,
is
sir,
over?
I understand. I understand.
So distance by time is nothing but length upon time, right?
Yes,
Distance
sir.
is a kind of length.
Yes,
Yes,
Distance is
sir.
a kind of length.
Yes, sir.
Everyone.
Yes, sir.
Yes.
So this is length upon time. Okay, length upon time. That is what? Velocity. Length upon time is what? Velocity.
Velocity.
So length is a fundamental quantity and time is a fundamental quantity, and that is being required by velocity to get defined.
Yes,
I
sir.
hope you
Yes, sir.
understand,
Yes,
Yes,
sir.
sir.
right?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. So this was the difference between fundamental and derived quantities. Shall we
Yes,
move
sir.
to the next page?
Yes, sir.
Okay. Next, we'll be dealing with the physical quantities. We have dealt with the fundamental quantities. We dealt with derived quantities. Now we'll be moving on to the process of measurement. How we'll be taking the measurement? What will be the units in different cases? Like we cannot use kilometer scale to measure 6 centimeter, right? Or we cannot use a centimeter scale to measure distance between two cities, isn't it?
yes,
Yes,
sir.
sir.
So how and when will be defining these things? That's how we have to use that. Okay. Now, the measurement process. What is the measurement first? I'll be writing about measurement. Measurement. What is the measurement? Right. So measurement. The measurement of a physical quantity. The measurement of a physical quantity. Measurement of a physical quantity is the process of comparing. Measurement of physical quantity is the process of comparing this quantity with a standard, amount of physical quantity of the same kind, called its unit. Okay,
Yes, sir.
written everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Tarun?
Yes. Wait a second, sir.
Nitish, done?
Yes, sir.
Sir, does this come under physical quantities?
Pardon?
Should we write this under physical quantities?
No, this is a totally different kind. We have to
Okay,
measure
sir.
both the quantities. Measurement
Sir,
is
finish.
done for both. Measurement is done for both fundamental quantities and derived quantities. So we
Sir,
have
I'm
to.
asking, should we write it under physical quantities?
No. That's what I'm talking about.
Okay, sir.
Okay, that is a different unit, and this is a different unit. Okay, because measurement is done for both derived quantities and fundamental quantities.
Yes, sir.
Okay, so what is measurement? Measurement, like if we have something, if we have a length. Okay, if you are measuring length, so how to measure length? We'll be measuring a length with a scale. You'll take a scale and then measure it,
Yes,
right?
sir.
Yes, sir.
So scale is already set to a standard value, isn't it?
Yes, sir.
That has already been defined by the scientist earlier. Okay, and then we are measuring with that particular quantity. So scale is already being set to the standard value. And okay, now you must have gone to buy some vegetables in the market.
Yes.
You must have seen that
Yes, sir.
Weight
we
machine.
generally buy vegetables in terms of kgs, right?
Yes, sir.
The standard
sir.
weight you must have seen there.
Yes, sir.
Yes, sir.
End of weight is there. Something like this.
Yes, sir.
1 kg, half kg, 2 kgs. Like this is written there. You must have
Yes.
seen this. Nowadays we are
Yes,
using
sir.
that electric
Weighing
one.
machine.
Nowadays that electric one is being used. But earlier we used to see this. I hope you must have seen that.
Yes,
Yes,
sir.
Different weights were there, and then the balance was there. Of course, the balance was there.
Beam balance.
Beam back.
The
Yeah.
beam balance was there, and then they used to balance the vegetables or fruits or whatever it was, and then we used to get the amount, right? And we used to pay for
Yes.
per kg price,
Yes,
isn't
sir.
it?
Yes, sir.
So we measure anything, any quantity with respect to the standard value already being set. The standard value is already set there,
Already said.
1 kg.
right? Per kg. Per kg is for mass. Length, it is there per centimeter or meter or kilometer, different units for different measurements. Okay. Then if you measure temperature, it's already been set in units, that is called Kelvin scale or Celsius scale or Fahrenheit.
Yes, sir.
We measure temperature based on this. I hope you must have heard these terms.
Yes, sir.
Isn't
We
it?
have heard. Yes.
Everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Sir,
Okay.
if olden age they didn't have any digital weighing machine, how would they
Pardon?
measure whether that particular mass is 1 kg or not? That solid.
Pardon. Do not hear that.
No, sir. Like on early time, they didn't
Hmm.
have any digital weighing machines.
Hmm.
How can they tell that that stone or that object is 1 kg? By which they used to measure?
1 kg was not asserted. See, earlier we don't even have, if you go long back, we don't even have that money. So barter system was there in the circulation, if you have heard that term.
Yes,
Okay.
sir.
We distributed things, like if I have more of wheat and you have more of rice, so I'll give some rice to you, and then I'll take some wheat from your side, or the same, right?
Yes, sir.
So
Yes, sir.
earlier that particular exact measurement was not done, and to some extent some scales were developed, to some extent some standard scales with respect to different countries or kingdoms. It was already been set so that they can measure or standardize the unit there. Okay.
Yes, sir.
Okay. Now, to express the measurement of any physical quantity, we need to know two things. I'm just changing the slides. Is
Yes, sir.
everyone done with it?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So to measure any physical quantity, we require two things. We need to know two things.
Should we write this up?
Yeah, you need to write this. Okay. First, the unit in which the quantity is to be measured. Second, the numerical value. Or the magnitude. Numerical value or the magnitude of the quantity. This can be also written as, that is, the number of times that unit is contained. Number of times that unit is contained in the given physical quantity.
Sir, can you tell the entire second point again, sir?
Where
The like the second word in the second point.
the numerical value or the magnitude of the quantity. Numerical value. See, I am writing it more properly.
So what's the last word in the second point?
This one,
Yes, sir.
given
Okay, sir.
physical quantity. Okay.
Sir.
Written, everyone?
Yes, sir.
Yes, sir.
Right? Okay. So two things we require to express any given physical quantity. One is the unit with which like in which we are measuring that particular quantity, and second one is the value of the quantity. Okay. Any measured quantity has got two things: the numerical value. Like if I say you, what is the length of your table? What will you answer? Approximately.
3 meters. Or wait, 2 meters.
Yeah,
Not
3
exactly 3
meters.
It's quite huge.
2
Huh?
2 meters.
Not even that. 3 meters is the
40
distance between.
3
inches.
meters.
So 1.2 to 5 meters.
Yeah, that's more precise. Who
3
said that?
meters. Exactly 3 meters.
Dude,
1.2
3
was-
meters is a lot.
3 meters is the distance between your floor and ceiling.
Yeah.
3 meters is the distance between your floor and ceiling. Okay, that's quite huge. Kongwe, that's large. Nearly
Sir.
2 meters, I think that is.
Sir, I remember the distance between the tip of my finger and my elbow is
Okay,
something like
these are
30
different units
centimeters.
you're using. Okay, yeah, different units. Okay, so basically you are giving me a value. All of you are giving me a value. I'm not exactly taking into consideration your answers, but what I'm considering is that you are giving me a value. Let us say 2 meter, and you're giving me a unit, right? You're giving me a unit.
Yes, sir.
You're giving me a value, and you're giving me a unit, right? So
Yes,
these
Yes,
two
sir.
things are required.
Yes,
That's what I wrote here. These two things are required to define any measurement,
Yes.
right?
Yes, sir.
Yes, sir.
Yes, sir.
Everyone. So this is the value part. This is the numerical value. Numerical value, and this is the unit. Two things that are required for any measurement: numerical value and the unit.
Unit.
So n into u I can write. N into u I can write. Isn't it? N
Yes,
is the
sir.
numerical value and u is the unit. Isn't it?
Sir.
Yeah.
N is the
Yes,
numerical
sir.
value and u is the unit.
Yes, sir.
Yes, sir.
So I can write n into u. Any doubt there?
No, sir.
No, sir.
Okay. Now I've changed the page. Okay, see here. If I say n and u is constant, that means n1 u1 is equals to n2 u2. What does that mean? What does that
They
mean?
are the
Yes.
same.
See here.
Sir, like N1 and V1 is like
Yes,
one.
u1. It's u1. n1 u1 and
U.
n2. Let me explain first. Okay. See here. n1 is the numerical value in the unit 1. Okay.
Yes.
These are different units. Okay, different units. Different units.
Yes.
Numerical values or values of that particular quantity is in different units. Values of same physical quantity in different units. This is what they are. Okay. Now, what does that mean? Like I have a stick. This is my stick, and I'm measuring it with a stick. I'm measuring it with a stick. Okay. I have got two scales there. One is inch scale on one side, and one is centimeter scale on the other side. Isn't it?
Yes,
You have
sir.
that there?
Yes, sir.
Inch
yes,
scale
sir.
on the other side and the centimeter scale on one side. So
Yes,
I
sir.
had measured
Yes, sir.
this the stick's length to be 15 centimeter. I measured it to be 15 centimeter. And with the other scale, I turned the scale to other side and I measured it to be 6 inches. 6 inches and 15 centimeter. So they both are different units and different values, na?
Yes, sir.
Yes,
They both are
sir.
different units and different values,
Yes, sir.
isn't it?
They both are different
Yes.
unit but same measure.
Yeah.
No, I'm talking about the numerical values, the numerals I've written here.
Sir, the values are not same, but the like both are not
Even
same.
units are not same. Even units are
Units
not
are-
same.
Yes, sir.
Kongwe, any comments here?
So it's 5.8, sir.
Okay, Kongwe, any comments here?
Sir?
Any comments on this? 15 centimeters and 6 inches. How they're relatable?
Magnitude is different, but value is same.
Even magnitude is not. Yeah, that's what you said. Correct. That is something correct. Okay. See, the length of the stick is same now. Either
Yes,
you
sir.
measure in centimeter or you measure in inches. But since you
same.
change the scale, the numerical value will also change. In order to equate the magnitude, in order to equate the physical quantity's value, okay, the value of this length of the physical quantity is to be same. You measure in any units. The value should be same. Okay, I hope you're understanding
Yes,
this. The value should be
Yes.
same. This length should be same. You measure in any units, but this numerical value is dependent on the units you are considering. If you are considering higher units, inches are somewhat higher unit than centimeters. 2.5 or 2.4 centimeters constitute 1 inch. So you are considering higher unit, so value will be less. You are considering a lower unit, so value will be more.
So
I'll
the
get-
higher, so higher the numerical value is going, the lower the value
Unit.
of the
Yeah.
unit is going.
Yeah. Higher the numerical value, lower the unit. But the quantities are same now. The
Yes, sir.
quantities are same.
Yes, sir.
Everyone,
Sir,
Yes, sir.
Sir.
any doubts there?
No, sir.
Right? So this is what I mean. In N1 system of units, if the unit is U1, so in U2 system of units, the numerical value will be N2. Okay, but the physical quantity will be same. you can relate it with. That's why I've said you the physical quantity is constant. You relate it with any physical unit. So that's why I've written 15 centimeters is equals to 6 inches, because they both are giving me the same physical value. Understood, everyone?
Yes, sir.
Yes,
So,
sir.
meter is N1 and inches is V2.
Tarun, is it fine?
Yeah, yes, sir.
Sankal,
Yes, sir.
Yes, sir.
Angwe,
Yes, sir.
and Nitish also fine with
Yes,
you?
sir. Yes, sir.
Okay. So now, as you said, Sankal, that numerical value is inversely proportional to units. Numerical value is inversely proportional to units.
Yes, sir.
Okay.
Universally
what-
proportional.
So higher the unit, lower the numerical value.
So can you wait a minute? I'll just copy this down.
Yeah. Simultaneously lower the unit. Higher the
So what?
numerical
N again?
value. Pardon?
N, sir. N.
I could not hear that. Please pardon.
1 second.
Yeah. So this is what I wanted to write here.
What is n, sir?
N is the numerical value, like in 15 centimeter. So 15 is n, and this centimeter is
Okay,
u. You can note it down now, everyone.
Yes, sir.
Yes, sir. Finished, sir.
Everyone written?
Yes, sir.
Yes, sir.
Okay, Kongwe. Kongwe, are you there?
Sir, I'm done. I just went to drink water.
Have you written this?
Yes, sir, I'm done. I just went to drink water.
Okay. So everyone has written this. Shall we move on to the next topic?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Right. Now we'll be dealing with desirable characteristics of physical unit. What are the desirable characteristics? How do we if you are just given with take any physical quantity and measure it? So it is upon you that what units you'll be taking, isn't it?
Yes, sir.
So what are the desirable characteristics? It should be well defined. It should be easy to use. The value should be quite in range, considerable range, isn't it?
Yes, sir.
Should not change with time. If the thing is like this, we have a stick, okay, and we measured. We have a stick here. Just a minute. Yeah. So we have to measure this. Like if this is a random sticks, a random thing, we have to measure this. Okay, we measured it with the tape because this is quite curvy.
Yes,
This is
sir.
quite curvy. So
No.
we'll be measuring with the measuring tape
No, sir.
to get a more precise answer.
Yes, sir.
So,
Ah.
so what were you saying, sir?
Like we have to measure something. Like we are considering something is given to us that to measure it. Okay, and it is left upon us that what unit should I decide? What unit should we decide? So how we can decide whether which will be the best unit? We have different units. So which one will be the best? It is dependent on us. So how will be describing that? See,
Well
different things
defined.
that should be well defined. That should be having convenient size. That should be indestructible. That should not change with time. That should be easily reproducible, easily accessible. These things should be there. Like say, if I'm measuring this length, this came out to be L. This length came out to be L, right?
The L
Okay.
should stay the same every.
And then after 5 years, this was a tree, let us say, and biological calculation was done on this. And after 5 years, my length of the scale contracted due to temperature change. Now it is this L is this much only.
Yes, sir.
So
Yes.
will not my calculation get altered?
Yes, sir. It will.
It will get
So that should
altered.
not be there, na. That should not be there, na.
Yes, sir.
So desirable,
Sir, but we can't do anything about it.
huh? No, we
can't do
can.
anything.
We can.
You have to change the measurement depending on how much
See,
you want.
We have different materials now. When you'll go for further studies in class 11th and 12th and beyond that, you'll be seeing there are different materials that are constant with respect to temperature, pressure, and other things, and it doesn't get changed. Okay, so there are basically alloys which are indestructible, not exactly indestructible, but they are more resistant to changes.
Yes.
So we can have accurate answers if the scales are made up of some standard materials that have already been set. Okay, so desirable characteristics of a physical quantity, or unit, not quantity, unit of a physical unit. Okay, what are those? Well defined. It should be well defined. It should be easily accessible. Okay, it should not vary with time. Should not vary with time. Okay, all these
Yes.
things should be there. Internationally acceptable. Internationally acceptable. Like if you're using some local unit and that is known by some group of people around your village or around your town or around your city, so that won't be accepted worldwide, na.
Yes, sir.
So when we measure generally with our hands, we used to measure. Okay, so like if we go to some international station, or like you measured your table with your hands and you said that it is 5 of my this arm length, 5 of my arm length, right?
Yes.
And you then called your friend to get you a tablecloth of 5 of your arm length. Will he be able to get the exact size?
No, sir.
No, sir.
Okay,
Unless
so
he's
that-
arm also.
but when you'll be saying that it is 2 meters or 1.5 meters or 1 meters, in that case it will be acceptable,
Yes, sir.
right? So these are the derivable characteristics of physical unit, not quantity, unit.
Done, sir.
Yes,
Done?
sir. Done. Done, sir.
Everyone?
Yes, sir.
Yes, sir.
Tarun?
Next.
Okay. Pongwe, done?
Yes, sir.
Okay. So now we'll be moving on to the next topic.
Yes, sir.
Yes, sir.
Next topic probably. Just a minute. Yeah, the next topic, and that is your fundamental and derived units. Fundamental. Just a minute. Yeah. Fundamental and derived units. Basically, we have two kinds of units: fundamental units, and derived units. Like we had fundamental quantities and derived quantities. Can anyone explain me what are the difference between fundamental units and derived units?
So derived units need fundamental units to get well defined.
Very good. That's nice. Everyone agree to
Yes,
this?
sir. Yes, sir.
Okay, everyone. Now,
Yes, sir.
physical units. Which can be neither derived, okay, nor simplified. Into more simpler units. And derived units are units which can be expressed in terms of fundamental units which can be expressed in terms of fundamental. First, you write it down.
Yes, sir.
Done, everyone?
Yes, sir.
Yes.
Yes, sir. Yes, sir.
Everyone done?
Yes, sir.
Congrats.
Yes, sir.
Yeah. So what is the difference between fundamental units and derived units? Like fundamental quantities and derived quantities. Fundamental
Physical-
units are the units which can
phys-
either be simplified into more simpler form, or which do not require any other units to get defined. Right, everyone?
Yes,
Yes,
sir.
sir.
Yes, sir.
Understanding? And
Yes, sir.
derived units are what? Derived units are
Derived
units
units
which
can
be
be-
We
expressed in
need
terms of
fundamental
fundamental.
units to get meaning.
To get meaningful. That's correct. Right? If I just
Yes,
give you an
sir.
example, time has the unit of seconds. Time
Yes,
has
sir.
the units of seconds.
Second.
These are fundamental units. And then
Distance.
distance.
Equals
Distance has the
length.
unit
Meter or something like that.
meters.
Sorry. Length. Meter.
Yeah, sorry. So distance is the unit of meters, right?
Meter.
Yes, sir.
Yes.
Okay. But in derived units, we can express velocity.
So mass weight.
Divided.
Meter
sorry,
upon
divided
distance
by
by
second
time.
square.
Per
Distance
second,
divided by time.
Meter. Oh, meter per square. Okay.
right? So meter per second is a derived unit which requires meters and seconds,
Yes, sir.
isn't it? To get defined.
Yes, sir.
I hope you have understood till here.
It's not
Everything?
square.
No.
Hey,
For velocity, it's
that
not
is
square.
acceleration.
Oh, sorry,
acceleration.
sir.
It is acceleration. Very good. It is the acceleration. Okay, everyone.
Yes, sir.
Yes, sir.
Even acceleration is a fundamental quantity, right?
Yes, sir.
Sir, no, sir.
It is
Exactly. I'm just
length,
checking you.
change in velocity divided by time
Who are
travel
attentive, I was just
or
checking
the
you.
time taken.
Sir,
Acceleration
you
is
said
a direct-
yeah, you said fundamental.
Oh, sorry.
I was just checking you.
Oh
Who
my
were all
God.
attentive there. Okay. So acceleration is a derived unit. Even acceleration, that is meter per second square, has got derived units because its derivation comes from velocity per unit time, and velocity is already having derived units, right?
Yes.
Sir?
No.
Not go in the flow. Yes, sir. Yes, sir. It
Sir,
should be attentive.
No, sir. No, sir.
Sir, I didn't hear you.
Okay. Everyone done?
Yes, sir.
Yes, sir.
Arun,
Yes, sir.
Yes, sir.
Satish,
Yes, sir.
Sankalp,
Yes, sir.
and Kongwe.
Yes, sir.
Okay. So this was all for this class. Okay. After this, we'll be moving into the further concepts. There are many more concepts to be dealt with. Basically, this topic forms the basic of physics. This chapter forms the basic of physics. So listen carefully. I'm trying to make you understand everything in the class so that you don't even require many revisions. Everything should get into your mind, but still revisions are required. You should go and open the book and read the things till what we have done. You should solve the practice sheets if provided. Okay. And you should revise the things, revise the notes also before coming to the next class, because I'll be asking questions. I don't
Yes.
I don't want you to study lots of hours. Okay. You just have to like provide 1.5 to 2 hours for physics, but consistently. Everyone will be attentive from the next class.
Yes,
Yes,
sir.
sir.
I won't be there, sir.
Yeah, Sankalp, any doubt?
So actually, there is also like the first chapter in our textbook. So how I know is like actually we still didn't get our school textbook. I saw the library. There was a textbook in the library, and this was the first chapter. So as we
Yeah.
didn't get the textbook in school, we started with the second chapter.
Motion in one direction.
Yeah, motion and
So they have started with motion in one dimension, right? in
Yes,
school.
sir.
Yes, sir.
So they have left this chapter.
No, sir. They did physical.
Sir,
They did physical quantities, but like for 2 minutes. or
just-
something, like a
Yeah,
brief.
just for one class.
Just for one class.
After
Sir,
that,
they-
like,
they
they did a
said
brief
that-
explanation. So that's it.
So the
Like a very
the teacher said that this chapter is going to be very tough without the textbook, so she started with the second one.
Exactly. Okay, no problem. I'll be providing all the concepts from the textbook. Okay. I have notes from the textbook. I have references. I have everything from your textbook, and all the concepts will be related to that only. So you just whatever you listened in the class, you understood that now.
Yes,
Yes.
sir.
Then that's what you have to do. You just have to revise the things in the next class and then come. Okay. Till now we haven't solved any numericals. Like if we consider any numerical in the class, you should solve more of them and then come to the class. Right?
Yes, sir.
With the doubt.
Yes, sir.
So don't take any tension. I'll be completing everything and you will be understanding everything like you understood in today's class, right?
Yes, sir.
Yes, sir.
So thank you for today. We'll be meeting the next class.
Yes, sir. Thank you,
Bye,
sir.
sir.
Okay then.
Thank you,
sir.
sir.
Bye, sir.
Bye, sir.
Bye.
sir.